Okay, so reciprocal trig identities. So in order to understand reciprocal trig identities, we have to know the three primary trig identities, which are your sine, your cos, and your tan. And what it's telling you is sine theta is equal to 1 over cosecant theta, cos theta is equal to 1 over secant theta, that's written very funny, and tangent theta is equal to 1 over cotangent theta. What the heck does that all mean? Well, first we're going to have to kind of define what the original sides are. So on the left side of each of these equations, I've written our original trig identities. So we're going to talk about breaking those down. Well, what is sine theta? Well, sine theta, if we're looking at a triangle, is the opposite side of the triangle over the hypotenuse, right? So what does that look like for a triangle? Let's bring a triangle up. No, I don't want to use that one. This one's a good one. First of all, it has to be a right angle triangle in order to use these primary trig ratios, right? So I'm showing you the primary trig ratio. So let's say that theta is this here. Well, that means the opposite is over here, hypotenuse over here. So sine is a complex equation referring to this angle theta, that's what this is here, which is then equal to the ratio of the opposite over the hypotenuse. So it's just setting up a ratio for you, okay? So with that being said, what would cosecant be equal to? Well, cosecant would be the reciprocal of this, okay? So in other words, if I were to write cosecant theta, what is it equal to with the idea of sine? Well, I'll write in red. Cosecant theta is equal to 1 over sine, okay? And we could kind of come to this conclusion algebraically. If I took cosecant and brought it to this side of the equation and then I divide by sine, we end up with cosecant theta is equal to 1 over sine. So what it's saying is it's equal to the reciprocal of this. And the reciprocal of this is the flipping of these two things. So this is also equal to hypotenuse over opposite. Nope, not theta, sorry. Nuts. Hypotenuse over opposite, that O there. So I should have done the other part in black. This was our sine, right? Our theta was here. There's opposite. Well, in our case, we take the hypotenuse and we put that on top of the equation. So we kind of start over here and then we divide by this. So it's the reciprocal. It's the flipped version of sine. It's just another way of stating a primary trig ratio, but we're using a different type of identity. So if you remember doing sinusoidal waves, sine x is essentially this. This is in our radians here, right? Well, what would cosecant x be? Here is our cosecant x. So it is the inversion of this. Now you don't have to really get into the flipping of all this, but it would be the inversion of all this stuff. The idea of 1 over sine x. And you'll see, if I turn off the blue one here, oops, sorry, no, if I turn off the green one here, they kind of overlap each other. Okay, so it's just saying that certain things are equal to each other. It's an equation that's equal to another equation. And the reason you got to know this is once you start proving trig identities, these will come into play on how to deal with them. So with that being said, we'll kind of build cos, secant, and tan and cotangent. So cos theta as a primary trig ratio is the adjacent side, I almost forgot what I said for, adjacent side over the hypotenuse, which means the secant theta would be equal to the hypotenuse over the adjacent. It's just the inverse of the original one. Okay? And for us to say they're equal to each other, you can kind of write it this way. You can say cos theta is equal to 1 over secant theta, or you can say secant theta is equal to 1 over cos theta. That's a way of showing equality between them. And then finally, same idea, tangent. Tangent theta is opposite over adjacent, which means cotangent theta is adjacent over the opposite. And to show that they're equal, tan theta, 1 over cotangent, and cotangent theta is equal to 1 over tangent. So why show us these? Well, you could kind of go through your normal trig ratios. Let's build another triangle again. Let's see if I can get a good triangle. Let's see if we have one like this. 5, 4, 3. It's a kind of a common right angle triangle. Okay. And let's say we wanted to find this angle here. Okay. I have all the sides, so I can really set up any ratio I want. So if I were to do sine theta, which is the unknown, is equal to opposite, which is 4, over the hypotenuse, which is 5. Or I can use another formula. I can use the new one we just learned. I've already forgotten. It's cosecant. That's what it is. My memory's terrible with this. Cosecant theta, our unknown, is equal to the inverse of that, 5 over 4. Now, calculators are usually set up so that they only have really one version of this. Let me see, do I get it? No, I don't. A cos might have done it. But you can essentially calculate using these also. They aren't usually built into your calculator. You might have it. But you could solve for theta using cosecant as long as you just inverted these qualities. Okay? Same idea with if we had done cos, you could have said cos theta, theta's our green, is equal to the adjacent over the hypotenuse, the adjacent is 3 over 5. Well, secant theta would be equal to 5 over 3. And same thing with tangent. Tangent theta is equal to the opposite over the adjacent. The opposite is 4 over 3, which means cotangent theta is equal to 3 over 4. I'll put theta in after. Okay. They're just reciprocals. They're flips of each other. And then you could do the same thing on decimals. You can kind of take a look at what they would all look like here. We'll turn 2 of them off. Let's take a quick look. Cos x and secant x. Very similar to the relationship between sine and cosecant. You'll see how they're very similar. Almost looks like a parabola. It's not, but it almost looks like a parabola touching at the maximum and minimum points of the wave. And finally, this one's a little tougher to look at. I'm not sure if you guys have ever actually graphed tan. There's tangent, and cotangent x is kind of just the flipped inversion of it. Okay, so this is where they give you the sides. What if they did the opposite and they gave us another wonderful triangle here, and they said that this is 20 degrees. Give us possibilities of sides, okay, and put them in all 6 of these forms. And what they mean by that is kind of set up the ratio on this side. So if I have 20 degrees, the first thing I can work with is, let's say I do sine. Sine 20 degrees is equal to what? Well, if I put it in a calculator, it's going to probably give me a very, very long answer here. Sine 20. Okay, so look at this. 0.342. That's approximately 0.342. Okay, well, I can kind of turn this into a fraction, right? A ratio is essentially a fractional idea. So there's 3 decimal places here, so I could also say that sine 20 is equal to approximately 342 over 1,000. Okay. Then I can go about all the stuff of reducing it. We're not going to focus on that. Maybe you reduce it, it comes down to a really small number. But what is sine equal to? Sine is equal to the opposite, that's what's on top, over the hypotenuse. Okay, well, the hypotenuse here is 1,000, or it could be 1. You could find any equivalent ratio, right? And the opposite of this 20 degrees would be 342. Okay, so now that I have that, if I have sine, so in other words, sine 20 is equal to this idea here, I can say cosecant. Cosecant 20 is the inverse of that, which would be 1,000 over 342. So there's one setup. What about the adjacent side? Well, then I can use cos to figure that out. Cos 20 is equal to... Now here it gets a little trickier because I have to make sure I do it within the same hypotenuse to build the same triangle. So let's do it this way again. Cos 20. Okay, so I can only go to 3 decimal places, and it worked out really nice here. It's going to be 9396. So maybe I'm going to say 939, but again, it's an approximation. Okay, so 939 over 1,000. Okay, well, the hypotenuse is 1,000. That makes sense. The adjacent side apparently must be 939. This is one of like an infinite number of triangles, because you can make the angles the same in a triangle. This one must be 90 degrees. That must be 70 degrees. I can like expand this triangle. Can I visually show you how I do that? Yes, I can. I can continuously expanding it with the exact same angles and get longer and longer sides. So there's an infinite number of answers here. We're just showing a set of possible answers. So with that being said, if that's cos, then secant 20 is approximately, again, 1,000 over 939. It's going to catch up. Sorry, it's lagging there. And then finally, that means tangent 20 degrees opposite over adjacent would be 342 over 939, which means cotangent is approximately, or cotangent 20 is approximately 939 over 342. This is just showing you a possible set of answers, right? That's how you'd build it backwards if you had the angles, and this is how you'd kind of build it forward. If they gave you the sides of the triangle, this is how you could go about finding the angle. And if you plugged all of these in, like sine inverse of this, cos inverse of that, tan inverse, cotangent inverse, you'd end up with the exact same angle every single time. I just didn't go through the process because I don't have these three on my calculator. I do have these.
If you did all those, you'd get the same answer?
Same angle every single time. Every single time.
Could you show me, like on a
Sure.
calculator?
Yeah.
Find a calculator.
I'll see if I can find one that has cosecant in that. I can definitely show you on the sine, cotangent, and tangent. So sine inverse, I think that stands for my sine inverse of 4 over 5 is 53.1. Cos inverse is 3 over 5. So are you seeing what ratio I'm putting in there?
Yeah.
Okay. 3 over 5. Exact same value. Tan inverse of 4 over 3 is that. And then technically I don't have to prove this. What I could just do is do the inverse because we already know sine theta is 1 over cosecant. So I could kind of, or cosecant is 1 over sine. I could say 1 divided by this and it would kind of give us some more of that information. But I'd have to find a specific calculator because mine doesn't have those. But they'll end up giving you the exact same angles too.